Now, what are the exponent rules? Okay, let's make sure we're very clear on the exponent rules before we get into the logs. So when do we add exponents? Okay, we add exponents when we multiply the bases, when we multiply exponents with the same base. Okay, so this is when we multiply. And really, I want you to pause this and answer these yourselves in your own words, and then you can check to see what I'm saying. But so we multiply when we add exponents when we multiply. Okay, and the reason is because we want to count the number of multiplications. Okay, so we want, that's how many multiplies we have, that's how many multiplies we have, we just want to count them, so we're going to add those together. When do we subtract? Well, we subtract when we divide. Okay, so when we divide. And really it's for the same reason. Okay, because we want to take away. We want to take away times when we divide. Okay, so we want to take away the multiplication when we divide. Okay, so that's why we're going to subtract. We're going to take away. When do we multiply exponents? We multiply exponents when we have power to power. Okay, because this is called power to power. Okay, the reason why we do this is because we want to count multiplication in groups, right? Because this is groups of powers. Okay, so we want to count them in groups. So it's really important to make sure we have this clear idea what the exponents rule. We're not just like randomly applying a bunch of rules. We understand exactly why these rules are being used, and essentially it's to do with counting. So the last question here is, do we divide exponents? Well, I kind of would like to say no, we don't, because we really don't. That's not really been any of our exponent rules. We've never divided exponents. But there is, so the short answer would be no, we don't divide exponents. But the more important answer, like the more deeper answer is actually we do divide exponents. We have seen divide exponents. So, you know, if you want to just have a basic understanding of it, and as a general rule, no, we don't divide exponents. But really, we have actually seen divide exponents. And what does divide exponents really mean? So if I scroll back here a little bit, I actually saw a divide exponent here. Right? I saw right here. This is not dividing exponents because this is divide, but I didn't actually divide the exponents. I subtracted them. This is a big mistake if you're going to divide exponents there. But I did see divide exponents when we talked about roots. So generally we don't divide exponents, but if you want to say yes, okay, so generally no, but there is a situation where we did divide exponents, and we divided exponents with the root. Okay, so if only time you would ever divide if you were rooting things. Okay, so only when doing roots. So if we divide and then we say we're going to divide exponents because we're dividing, that's wrong. But when we do roots, roots are to do with dividing exponents. Okay, and if you want to make a connection, that's where the connection is. The last thing here is, this is what we talked about before. We never apply exponents across plus minus. This never works, and I'll show you why. Because when we square things, we make a square. So this is an a plus b squared, right? There's my a square here. There's b square here. This is an a plus b squared. Now there's other pieces to the square. Here and here. Okay, there's my a plus b square. That's not the same as a square by itself and b squared by itself. These are not the same. We're missing these pieces. In fact, they're never the same. A squared plus b squared squared is this shape. A squared and b squared together is this shape. They are not the same shape. They do not go together. So this is, try to get that out of your math. The last part here then is we're going to look at is solving this. Now, how do I go about solving something like this? Well, I could kind of guess at it, but if I recognize that I can express both of these as a base 3 number, I can make this argument. I can make the argument that if the bases are the same and the numbers are the same, the exponents are the same, and I can make this equality. And if I make this equality, I can solve for x. X is 3 over 2. And if you try this in your calculator, 9 to the power 3 over 2, you will get 27. We'll look at this a little bit more as we move into this unit.